Hello guys, today I have prepared a video for you about earthquake. Before you watch the video, please subscribe to my channel and share the video with your friends, okay? Do you guys have any idea about gravity? Gravity has always existed, but people didn't know it existed. One day, Isaac Newton, a scientist, was walking in the countryside and got tired and wanted to rest under a tree. There he fell asleep. At that moment a ripe apple decided to fall to the ground and landed on the sleeping man's head. When the man woke up, knowing that the world was spinning, he asked himself the question. If the world is spinning, this apple should have flown away from the earth instead of falling to the ground. Why did it fall to the ground? That's why he climbed to a high place and dropped a heavy iron from there. Of course, the iron immediately fell to the ground. Then he dropped a bird feather into the gap. Since the feather was very light, it floated in the air for a while because of the breeze in the air and continued to descend slowly, and finally landed on the ground. After doing a lot more research on this, Newton realized that the Earth has a gravitational force and called it gravity. In this video you will see a space rocket taking off. The gravitational pull of the Earth is so great that in order to overcome it, it needs a very high energy. The smoke emitted during firing will give you an idea about this. Let's give another example from our home. Let's take a look at the washing machines used by our mothers. When she does the spinning process, she takes the water out of the clothes and sticks the clothes to the outer wall of the machine. If there was no boiler inside the machine, the laundry would be scattered around. This force exerted by the washing machine is called the centrifugal force. Our Earth is also spinning, and with this spinning motion we or the seas and mountains should be tossed and spread out into space. But they don't. This is because of gravity. Because of gravity, our Earth does not throw anything that is in it out into space. All celestial bodies have gravity. For example, the Sun uses gravity to keep the 8 planets gathered around it from flying into space. The Moon also has a gravitational force, and many of the movements that occur in our world are due to the Moon. For example, the tides that recede for a while and then come back are related to the gravitational force of the Moon. You will learn more about this in the future. At the moment, I am telling you this even if it is unnecessary information, just to keep it in the back of your mind. The gravitational force of the Earth is called momentum and is expressed by the letter g. G is the constant that represents the acceleration of gravity. On Earth it is usually expressed as 9.8. This value shows how much an object accelerates every second as it falls. The Moon's gravitational acceleration is approximately 6 times lower than Earth's. The Moon's gravitational acceleration is about 1.6. This makes people feel lighter and move more easily on the Moon than on Earth. This is why astronauts can move more easily on the Moon, feeling as if they are walking with a light bounce. Let me explain it this way. For example, when you stand on a scale on Earth, you can find out how much you weigh. Have you ever thought what would happen if you stood on the same scale on the Moon? Yes, you will look much lighter. So a child who weighs 30 kilos in the world will weigh only 5 kilos if he steps on the scales on the Moon. On a planet with a very high gravitational pull, he will look heavier, and this will be reflected in his movements. The same man who jumps up and down on the Moon will move much slower and tire more quickly on the other planet. Let's give another example of gravity. In space, astronauts work in zero-gravity environments. On the International Space Station, ISS, gravity is very low, so astronauts move almost glidingly. If they let go of something, it doesn't fall into place, instead, it floats through the air. This is an example of a different experience in an environment where gravity is not as effective as on Earth. Experiments like this are important to help us understand the effects of gravity and how it behaves in space. No astronaut can go into space without this training.